to start off the trigonometry video by talking about the unit circle. The unit circle. Unit means 1. That is, the unit circle is a circle of radius 1. X squared plus y squared is equal to 1 squared, or 1. That's the equation of the unit circle. Now, let's verify some points are on the unit circle. Verify that, I guess 3/5, 4/5. This point is on the unit circle. Call it UC. Well, that's the x value and that's the y value. If to get on the circle, the unit circle, if you square the x value and you square the y value and you add them up, you have to be 1. If you're not 1, you're not on the circle. Well, it's 3 over 5 squared. 3 squared over 5 squared. 3 squared is 9. 5 squared is 25. Plus the y value squared. 4 over 5 squared. 4 squared over 5 squared. 16 over 25. Well, since the denominators are the same and we're adding, you keep the denominator and you add the top numbers. 9 plus 16 is 25. And we do get 1. This point is on the unit circle. Okay, let's try another one. How about this point instead? How about, let's see, 5 over 13 and negative 12 over 13. How about that point? The point 5 over 13, comma, negative 12 over 13. Well, if you square the x value and you add to that the result that you get when you square the y value, you're supposed to get 1. Well, 5 over 13 squared. 5 squared is 25. 13 squared, I guess, is 169. Plus negative 12 over 13 squared. Well, 12 squared is 144. Negative 12 squared, is 144. Negative times a negative is a positive. 13 squared, 169. Where in addition, the denominators are the same. Keep them. Keep it the same. Add the tops. 25 plus 144 is 169. We are getting 1. That is x squared plus y squared equals 1. That's how you get to be on the circle. If you didn't get 1 and you didn't make a mistake, then the point was not on the circle. Okay, let me erase my board, please. Okay. Now, in our trigonometry, we have angles. They're measured in degrees, and they're also measured in radians. Just like length is measured in feet, and it's also measured in meters. Now, pi radians, this is the units, is equal to 180 degrees. Now, you need to listen to what I'm saying carefully. If it's understood that you're talking about a degree measurement, well, of course, if it says degrees, it's degrees. But if there are no units, if it just says pi, then it's understood, and it's clear that you're talking about angles. It's understand to be pi radians. If somebody says 7, and it's understood to be an angle, then it's shorthand notation for 7 radians. If it's understood to be an angle and there's no units, then it's radians. No units, understood to be angles, and I'm telling you this is an angle, then it's 7 radians. If I tell you 13 degrees, well then it's clearly an angle and it's 13 degrees. You can have pi degrees, regardless of what people tell you. You can have approximately 3.14 degrees. You can have any number of degrees. If there are no units and it's understood to be an angle, then the units are radians. And what you need to remember big time is that pi radians is equal to 180 degrees. You need to know that like your name. When you study trigonometry, you have to know pi radians is 180 degrees. Okay. So we want to sketch on the unit circle. If I tell you that the angle is equal to, say, pi over 4. Okay. Now remember, pi, most people understand degrees better. Well, actually, let's stay away from that. So here's the unit circle. And 100, you measure angles off the x-axis in counterclockwise direction. Positive angles go in that direction. Positive angles go in that direction. For the record, negative angles go in the opposite direction. So we want to go pi over 4. Well, if you go all the way out to here, then you are pi radians. If you go halfway, half for pi would be up here. Well, notice that if you take half for pi, then you get pi over 4, which is halfway. 180 was here, pi was here, pi over 2 is there, and a quarter pi is here. 1/4 pi, 2/4 pi, better known as half for pi, 3/4 pi, 4/4 pi, which is pi. So the answer to the problem is this. Sketch T. Pi over 4. Sketch T. Okay, do some more of these. Now that I confused you. What does somebody ask you to do? 7 pi over 4. Okay, sketch 7 pi over 4. T is equal to 7 pi over 4. You should think of this as pi over 4. 7 of them. 7 pi's over 4. Well, here's 0. Here's 1 pi over 4. Here's 2 pi over 4, better known as a half. Here is 3 pi over 4. Here is 4 pi over 4, or pi. 5 pi over 4. 6 pi over 4, better known as 3 pi over 2. 7 pi over 4. And here is 8 pi over 4, or 2 pi. Now remember, since pi is 180 degrees, 2 times pi is 360 degrees, which meant we went all the way around the circle. This is also 0 pi over 4 right here. So the answer to our question is right there. Here it is. 7 pi over 4. This angle right here is 7 pi over 4. I start from the x-axis and I go in a counterclockwise motion. 7 pi's over 4. And you should know where pi over 4 is. And then you should know where another pi over 4 is and where another pi over 4 is. What if you were asked to draw t is equal to pi over 3, negative? Negative means go in the opposite direction, go in the clockwise direction. Now remember, here is 0, pi over 4, here is pi over 2 or negative pi over 2, here's negative pi, here's negative 3 pi over 2. Remember, if pi is equal to 90 degrees, then pi over 2 is 90 degrees over 2. Excuse me, if pi is 180 degrees, then pi over 2 is 180 degrees over 2, which is 90 degrees. And you all should know 90 degrees. Here's 90 degrees, that's negative pi over 2. Another 90 degrees, another pi over 2. You take away half for pi, and then you take away another half for pi, you took away 1 pi. And then you take away another pi, you took away 1.5 pi. Okay, so we want to do negative pi over 3. Well, what you need to just know is that, okay, so we know that pi is all the way up to here. We want to break this up into 3 pieces. This piece right here, this piece in the middle, and then this piece. Those are each pi over 3. That is, here is my answer right here, negative pi over 3. You should just have this line. I took pi and I broke it up into 3 pieces. What if somebody asked me to go negative 2 pi over 3? Well, negative just tells me the direction I'm going. I'm going in the clockwise direction. Sketch, t is equal to negative 2 pi over 3. Well, think of it as pi over 3's, but you're going negative 2 of them. Negative 2 pi over 3. Well, since it's negative, we go in the opposite direction. We know all the way up to here is negative pi. Break it up from the center into 3 equal pieces, like such. Here's 1 pi over 3, here's another pi over 3, here's the last pi over 3. We want to go 2 of them. Okay, let's go 2 of them. 1, 2. 1, 2. Here is your answer. Here is your answer. Let me draw it nice and neatly. Okay, here it is. Negative 2 pi over 3. What if I ask you to go 1.7? What if I said that t is 1.7? Well, on the unit circle, actually, I guess I've been making a very slight mistake in all of these problems. Nothing major. We'll talk about it right now. You should know that pi as a number is 3.14. Even at an angle, pi radians is 3.14 radians. Okay, pi radians. If I divide by 2, I get pi over 2 radians. Oh, pi is approximately 3.14. It's a little bit more. Well, when I take half of 3.14, I get 1.57 radians. Okay, but I want to go more than that. Since there's no degree symbol by the 1.7, and we're telling you it's an angle, is understood to be 1.7 radians. It's a little bit more than 1.57 approximate. That is, it's a little bit more than pi over 2. Well, pi over 2 is right here. I know, because if pi is right here, if all of this is pi, then if I go halfway, I go pi over 2. I'm going to go a little bit more than halfway. And like I said, I've been making a slight error. I'm sorry about that. I've been drawing my line way out here. The error is I should be stopping right at the circle and saying, there's my answer. Okay, here is 1.7 radians. I should not have ever gone past it. Okay, otherwise, we're not using the fact that we're on a unit circle. So in the previous ones, I'm sorry, we should have stopped right on the circle. Okay, what if we do one more? What if I tell you t is 7? What if I tell you t is equal to 7? T is equal to 7. Well, we know that pi is approximately 3.14, and 2 pi is approximately twice that, 6.28. Or we're more. Well, how much more? Do we go more than half for pi more? Well, based on this, half for pi is 1.57. Now if I add these, 2 pi plus a half for pi, well, that's 2.5 pi's. This is approximately 7.85. More than 7. So I should go between 2 pi and 2.5 pi's. Well, 2 pi would bring me all the way around, and another half for pi would bring me up to there. But I'm not supposed to go that much. I'm supposed to go more than 2 pi, but less than 2.5 pi. So I'll stop right there, somewhere in the middle. There it is. This angle is 7 radians. It's understood to be 7 radians. So you have to get a feel where 7 is, because 7 doesn't have pi's in it. 7 is just, it's not 7 pi or 2 pi or pi over 9. It's just 7. Everything is on a unit circle. Okay, suppose I tell you t is the point. T is the point 4 over 5, comma 3 over 5. And they want us to find where pi minus t is, or negative t, maybe it's a good one, pi plus t, and then maybe the last one, 2 pi plus t. Alright, so let us find out where t equals first. Let's see where t equals, or where t is. X and y. value is 1. This distance is also 1. Since it's to the left of the origin, it's going to be negative 1. The x value right here is negative 1. The x value right here is positive 1. Up here, since I went up 1, the y value will be 1. Since to get to this point, I go down 1, the y value will be negative 1. Well, I'm told that x is 4 over 5 for t. X is 4 over 5. Maybe that's right here. And y is 3 over 5. So t is going to be right here. That's exactly where t is. Now we'll do part A last. Let's do part B first. That's when we should do part B before we do A. Well, how did we get to t? We went in the positive direction exactly that amount off the x-axis. That is, I started on the x-axis, I went to t. Well, to get to negative t, just go back the same amount. Right here is negative t. Now, what point will that be? Well, the x value is right there. I just went up and I looked. It's 4 over 5. The y value, now remember, this point came to be on the unit circle because 4 over 5 squared plus 3 over 5 squared is equal to 1. Well, negative t has to live up to that as well. I know x is 4 over 5, and I square it. The y value I don't know, but I know when I square it and add it to 4 over 5 squared, I'm going to get 1. Well, there's only two possible numbers that could go there. Either 3 over 5 or negative 3 over 5. Since the y value is negative, it's going to be negative 3 over 5. Okay, from this equation here, we know that if you're starting off with 4 over 5 squared, like we did there, and we're ending up with 1, you have to be adding 3 over 5 squared or negative 3 over 5 squared. Okay, so that took care of part B. How about part A now? We want to do pi minus t. Well, this is the same as negative t plus pi. Now pi is halfway around the circle. Now that I know where negative t is, it's right there, I just go halfway around. I go right there. I go halfway around. So I added pi. This is negative t plus pi, or pi minus t. Now, the question is, what point is that going to be? I just want to think for one moment, please. Okay. So you can read off the y value. It's 3 over 5. The y value is 3 over 5. And the x value, it has to be 4 over 5 or negative 4 over 5. Okay, what do you square and then add to the y value, 3 over 5 squared, to get 1? Well, there's only two answers, plus or minus 4/5. We got that from the very beginning. They told us that this point lies on their circle, unit circle. That is, if you square the x's and square the y and add them up, you get 1. Okay, since this x value is negative, to the left of the origin, it's going to be negative 4 over 5. So that's the answer to A. Now, since I drew in this a lot, let me get a whole other diagram, and we'll do letter C. So we still have the same idea that 3 over 4 squared or 4 over 5 squared plus 3 over 5 squared is equal to 1. And now I'm going to do letter C. Okay, we know where T is. T is right here. It's 4 over 5, 3 over 5. And I'm going to add pi to it. Remember, pi plus t is the same as t plus pi. So here's t and I add pi. That means I go halfway around. I go exactly 100 pi radians, half the circle. Alright, well, the x value is negative and the y value is negative. It's negative 4 over 5 and negative 3 over 5. Okay, that's C. D is pretty straightforward. 2 pi is the whole circle. Remember, pi was half the circle. Pi was 180 degrees. Well, that's half the circle. 2 pi is the whole circle. This is the same as starting off at t and adding 2 pi. Okay? I will start off at t. T is right here. And I go 2 pi. And there's my answer. I ended up back in the same exact place. Okay, that finishes that problem. You need to think about these. You add pi or take away pi, what's going to happen to the point that you move from? If you're at point T and then you add pi, what happens? Okay. The next one is important. Find the reference angle for each. And maybe you have 5 pi over 4, and you have 4 pi over 3, and 11 pi over 4, or 11 pi over 6. That's letter C. Now, maybe it's easier to convert these to degrees, something we're more familiar with. 5 pi over 4. You want to change the way it looks. You multiply by 1. I don't want radians. It's not in radians because there's a pi. It's in radians because there's no units. It's understood to be radians. So I'm going to multiply by 1. 180 degrees over pi radians. The radians are understood to be there. The radians are understood to be there. The pi's cancel. The radians cancel. What we're left with is 5 times 180 degrees over 4. Well, 4 goes into 180 90 times. How about 45 times? 4 goes into 180 45 times. 5 times 45 is 225 degrees. So, let's draw that angle and then we'll find the reference angle. Well, I just went 180, and if I continue up to there, I would have added 90 more degrees, and now it would be 270 degrees, which is more than I want. So you know what? If I take away 180 degrees, the amount that I already went, I'll figure out how much more I have to go. And I have to go 45 degrees more. So here is 225 degrees. That is this And here's my angle. That's the angle 225 degrees. Oh, here's the x-axis, here's the y-axis. To complete the triangle, to draw the third side of this triangle, always go to the x-axis. Don't go to the y-axis. Always go to the x-axis. The reference angle is the one that's caught right here, inside that triangle. And that's 45 degrees. After all, we went 180, we went 180, and then we went 45 more. Okay, so now to answer this, okay, the reference, REF, the reference angle of that is how much? Now you may say, oh, I know that answer we just did. It's 45 degrees. Yes and no. They gave us the problem in radians. We should give the reference angle in radians. Okay, you want to get rid of degrees, multiply by 1. If you want to change the way it looks, multiply by 1. Put pi radians over 180 degrees. The main thing is degrees cancel out. And it turns out that 45 goes into 180 still 4 times. And you're left with pi over 4. Pi over 4 radians. So the answer is the reference angle of 5 pi over 4 is pi over 4. It's the angle inside the triangle that you get at the end. Let's do the next one. Pi over 3. What's the reference angle of 4 pi over 3? Well, 4 pi over 3 is 4 times pi, but pi is just 180 degrees, over 3. 3 goes into 180 60 times. 4 times 60 is 240 times degrees, 240 degrees. Okay, so I go 240 degrees. I go 180, and remember, if I go all the way to here, it's 270. So I stopped before. Okay, call that 240. Nobody's going to take a ruler and make sure, or a compass, and say, oh, no, that's really 238. As long as you get it in the right quadrant, that's where one is looking for. Okay, so I went 180, and so I finished the triangle by going to the right, to the x-axis. I went 180 and then some more. How much more? Take away 180, and you'll see you went 60 more. So this angle in here is 60 degrees, and that's your reference angle. You have to convert it to our radians. Now you can be slick and say, well, that's 180 degrees, and 180 divided by 3 is 60. So there it is, pi over 3. Or, the long way is 60 degrees is equal to 60 degrees times 1. And my 1 is pi over 180 degrees. After all, pi equals 180 degrees. So when I divide them, I get 1. Now what happens here is a few things. The degrees cancel out. And 60 goes into 180 3 times. And I'm left with pi over 3. And that's my reference angle. Pi over 3. Okay, now we go on to letter C. I want the reference angle of 11 pi over 6. So it's probably best to convert it to degrees, draw their angle, find the reference angle, all in degrees, and then convert it back to radians. Now, instead of pi, you can just put 180 degrees. That is pi. So 11 pi over 6. And 6 goes into 180 30 times. 11 times 30. Well, 11 times 3 is 33. 11 times 30 just has a 0. And don't forget the degree symbol. If you prefer, you can do it the way I showed you. Take 11 pi over 6 and multiply by 1. 180 degrees over pi radians. The pi's cancel out. So you really have 11 times 180 over 6. Or 11 times 180 degrees over 6. 6 goes into 180 30 times. 11 times 30 is still 330 times degrees. It's 330 degrees. And you have to know your 90s. 90, 180, 270, and if I go all the way up to here, it'll be 360. So I'm somewhere in the middle. I'm somewhere, say, right here. Well, okay, so now I finish by going all the way to their x-axis. And I have a right angle there, always. Okay, so the question is how big is this angle? Well, we know that this piece is 330. Now, let's make a mistake. Let's make a slight mistake. If I go this amount, I win 360. Okay? And then, if I take away the part I don't want, because I only want that angle inside the triangle. If I take away this portion of the angle, I get exactly what I want. I get exactly this angle. But I know what I took away. I took away 330. I took away 330 degrees. So what's left is 30 degrees. That's the reference angle. Now, you can say 180 over 6 is 30, and that'd be your answer. The reference angle is pi over 6. If that's too complicated, no big deal. 30 degrees is equal to itself times 1. Pi over 180 degrees. The degrees cancel out. 30 goes into 180 6 times. All that survived was pi over 6, like I said. So the answer is pi over 6. Let's do one more. What if I say 2 pi over 3? Let's end up in the second quadrant. What if you end up in the second quadrant? Find the reference angle of 2 pi over 6 over 3, excuse me. 2 pi over 3. Well, what is 2 pi over 3? 2 pi over 3 times 180 degrees over pi. I put the degrees in the top because I want to end up with degrees. The pi radians, or the pi's cancel. 3 goes into 180, or 3 goes into 18 6 times with a 0. 2 times 60 is 120 times pi. It's 100 times degrees, excuse me. It's 120 degrees. So let's draw this. Well, here's 90. If I go one more 90, I'll be at 180. So I know I end up in the middle somewhere. Just go to the middle so you can have a nice room to draw the triangle. Like if it's 179 degrees, don't go to here, because it's going to be a pain in the neck to draw the triangle. Always end up in the middle. The only time you don't end up in the middle if your teacher goes out of their way to say, if you know, draw it exactly to scale. Okay, so here is our reference angle. We know up to here in degrees is 120 degrees. So how do we find out what this is? Well, make a mistake. Go this amount. Go 180 degrees. And then say, oops. Again, our goal is to find out this angle right here. Our goal is to find out this angle. Boy, did I miss it by a lot. I included all of this that I didn't mean to. I didn't mean to include any of that. But you know what? I know just how big that is. It's 120 degrees. So just like I did, visually, I'm taking away 120 degrees and I get 60 degrees. In here, 60 degrees. But since we're given it in radians, we have to respond in radians. Again, you can say 180 divided by 3 is 60 degrees. Or you can say 60 degrees is equal to itself times 1. Pi radians over 180 degrees. The degrees cancel out top to bottom. 60 goes into 180 3 times. All that survived were the pi and the 3. Pi over 3. Just like I said. You should know how to divide pi by numbers. It'll make life easy. That's what I think is good to review that. You should definitely know this table here. You should definitely know this. If you know this, life will be a lot easier. You should know that pi is 180 degrees. Big time, you should know that. 180 over 2 is 90. 180 over 3. So let me write it down that way. 180 over 2 is 90. 180 over 3 is 60. 180 over 4 is 45. 180 over 5 doesn't come up very much, but it's 36. 180 over 6 always comes up, it's 30. And you don't really need to know that one. You should definitely know this. You should know how to divide 180 by 2, 3, 4, and 6. 4 numbers. And 180 is the same as pi. So it's 180 over 2. It's 180 over 3. 45 is 180 over 4. There's a record 36. Well, let's say degrees, so this is correct. Our 36 degrees is pi over 5. 30 degrees is pi over 6. Okay, 180. When I see this, and I want to think degrees, I think 180 over 6. 180 over 5. 180 degrees over 4. 180 degrees over 3. Okay, you should definitely know those, 4? Okay, you don't really have to know this one. It's not wrong, but we don't generally divide pi by 5. We divide it by 2, 3, 4, and 6. Okay, know those. And if you know those, you're in good shape. If somebody gave me 210 degrees and they said, convert this to radians, well, I would say, you know what? I would think these numbers. I would think of these numbers and say, aha, 210 is 7 times 30 degrees. And I know how to write 30 degrees. 30 degrees is pi over 6. So I have 7 pi's over 6. If somebody gave me 330 degrees, I would say, oh, 330 is 11 times 30. And 30 is pi over 6. So here's 11 times 30 degrees. 30 degrees is pi over 6. If somebody gave me 225 degrees, learn your 45 table. 225 is 5 times 45 degrees. Here's my 5. 45 degrees is pi over 4. So you have to know your times table. You know your 45 times table? 45, 90, 135, 180, 225, 270, 315, 360, you're in good shape. If you learn your 45 times table, you'll save lots and lots of minutes on studying. That is on homeworks. Or you spend more time on homework. Me personally, I have better things to do than math homework. Okay. So, let's just do one more with negatives. What if I ask you to find the reference angle of negative 7 pi over 3? Okay, well, let us figure out what 7 pi over 3 is. Instead of pi, you can put 180 degrees. Remember, this is 7 times pi over 3. Well, 3 goes into 180 60 times. 7 times 60 is 420 times degrees. So where is this? Well, it's more than a whole circle because the whole circle is 360. But if you go up to here, you would be at 360 plus 90, which is 450, which is more than what we want. We only want 420. Okay, that is, it ends up somewhere in what's called the first quadrant. So here it is. All of this is 420 degrees, or 7 pi over 3. Now, the question is, what's our reference angle? Draw the triangle to the right, to the x-axis. What is this angle right here? What is that angle? Well, we went 360 degrees, and then we went some more. We went 360 degrees, and then we went some more. Well, if I take the 420 and I take away the 360 degrees, I'll see how much more I went. I went 60 degrees. So the reference angle is 60 degrees. And 60 degrees is 180 divided by 3. That's 60 degrees. So there it is. The reference angle. Oh, excuse me. I did all of this wrong. Sorry. The reason it's all wrong is that I didn't go negative. I need to go negative 420 degrees. Sorry about that. Negative means go clockwise from the x-axis. Negative 90, negative 180, negative 270, negative 360. I have to go some more. How much more? 60 degrees more. Okay. Complete the triangle not by going to the y-axis, but by going to the x-axis at a right angle. Okay. The reference angle is this, which is 60 degrees. And 60 degrees happens to be pi over 3. Reference angle is never negative. It's not negative. It has no direction. How big is this angle? Oh, that angle is 60 degrees. In a triangle, you can never have a negative angle. Okay, that finishes up the first lecture in trigonometry. Good luck with it.